In this video, we're going to talk about metallic bonding, and then we're going to use our understanding of metallic bonding to explain some of the characteristics of metals. We already know that metals are solid, they're hard, they conduct electricity and they conduct heat, and then they're also malleable and ductile. In other words, they can be shaped and molded and dented. But why do metals look and act this way? Well, it all comes down to how the metal atoms are bonded to each other. Bonding is all about the electrons. Whether we are talking about ionic, covalent, or metallic bonding, it comes down to what the electrons are doing. The electrons in metallic compounds are uniquely able to travel freely throughout the entire compound. It's kind of like the idea of a big event, like a sporting event. And if you've been to one of these, you may have seen somebody toss a beach ball up into the air, and you've seen that batted around as all the people kind of hit that beach ball all over the place. It just moves randomly all over the place. This is kind of like what the valence electrons of a metal atom are doing. If you can imagine that all the people here in the stands represent a metal atom, and this beach ball is representing the valence electron of one of these metal atoms. It just can move randomly throughout the entire stadium. Now, a bit of a better representation is if you can imagine if everyone were to bring a beach ball, at least one, because metal atoms usually have at least one valence electron. And if all of these things are moving around randomly, you can imagine it would get pretty chaotic. But that's kind of the idea of metallic bonding. All of the atoms are going to share those electrons all the way throughout the substance. Now, if you were looking up from the field, you may not even see any of the fans at all. You just see beach balls moving all over the place, almost like a sea of beach balls. And this is what scientists call the electrons in the metal atoms. It looks like a sea of electrons. It's just kind of moving all over the place. And so the electrons are just free to move all over. And you can see in red here, we have our metal cations. You can see these things right here, the metal cations. And then we could also say that the electrons are delocalized. And this word just means that the electrons are kind of free to move throughout the entire compound. Now, this sea of electrons can allow us to explain some of the characteristics of metals. Let's just start with the fact that metals can conduct electricity. So electricity is defined as flowing electrons. And when we have a power source like a battery here, the electrons are going to flow through a wire or something in one direction. And they'll just continue to move. Instead, in a circuit, we actually call it an electric circuit. It's kind of like going back to our stadium idea. If there was a big gust of wind that would come through and blow just in one direction across the stadium, you can imagine that all these beach balls would start to move all in the same direction across the stadium. And that's how electricity works. It's electrons moving together in the same direction. Now, the only difference here is that in electricity or electric circuit, the electrons would continue to be added to this side of the circuit, and so we would never have an end to those electrons as long as we had a power source. One other property that this sea of electrons can help us to explain is the fact that metals are going to be ductile and malleable. In other words, they can dent them. And so if we can hit this metal here with a hammer, those cations there you see in red would be able to slide past each other, but they wouldn't be able to slide too far because these seas of electrons, all these electrons here, are still going to hold them in place pretty well. So it keeps them a solid, but gives those atoms a little bit of movement. And that's metallic bonding and some of the properties of metals.